In this video, we're going to learn how to convert fractions to decimals. So our learning target is I can convert any fraction or mixed number to its equivalent decimal. And in order to do this, we're going to look at three different methods. So the first method is the simplest one. It doesn't work for every fraction, but I do like to use it when I can. And it's to find an equivalent fraction with 10 as the denominator. So whatever fraction you have, if you can find a fraction that's equal to that with 10 as the denominator, then it'll be easy for you to convert it to a decimal. So let's look at what that means. So here's 1/5. 1/5 would look like this as a model. I have a pie cut into 5 equal pieces, and one of them is shaded in. So to find an equivalent fraction with 10 as the denominator, you have to think about, what if I cut that same pie into 10 pieces? How many pieces would I have to shade in order for it to be equivalent to 1/5? So in the model right here, you see that I have the same size pie cut into 10 pieces, and I shaded in the same amount as I did over here with 1/5, but instead I have 2 pieces shaded in. So 1/5 is equal to 2/10. Now, it's tricky to do this by hand though sometimes. So if I'm trying to use models to help me figure out equivalent fractions, it's not always so easy. So there's a mathematical way you can do this as well. So we're going to start by figuring out what 1/5 is equal to as a fraction with 10 as the denominator. And what I'm going to do to figure that out is start by listing the multiples of 5. So I have 5, 10, 15, 20, and so on. And again, I just want to get to 10 as the denominator. So here's the 10. 10 is actually 5 times 2. So in order to find a fraction that's equivalent to 1/5, I have to multiply the top and the bottom by the same number. In order to get to 10 from 5, I multiply it by 2. So I'm going to start by multiplying the denominator by 2, and I have 10. And because I multiplied the denominator by 2, I have to also multiply the numerator by 2. So 1 times 2 is going to be 2. And you might be thinking, but I thought we were converting these to decimals and now we have a fraction. But we know that 2/10 written as a decimal is going to look like 0.2 or 0 and 2/10 because that 2 is in the tenths place. So 0.2 or 2/10 is equal to 1/5. So 0.2 or 0 and 2/10 is our final answer. So your turn. You're going to write the below fraction in its equivalent decimal form. So take a minute to figure out what 3/5 would be equal to as a decimal. And I encourage you to use the method we just reviewed together. So let's talk about how you can find your answer. So again, we're going to start with 3/5. We're going to find a fraction that's equal to 3/5. And we're going to start by listing my multiples of 5. So I have 5, 10, 15, 20, and so on. But again, I just want to get to 10. And I know that 10 is 5 times 2. So I'm going to multiply my denominator by 2 to get 10. And then whatever you do to the denominator, you also have to do to the numerator. So I have 3 times 2 is 6. And now 3/5 equals 6/10, and 6/10 written as a decimal looks like 0.6 because that 6 is in the tenths place. So 0.6 or 0 and 6/10 is our final answer. Let's look at another method. So this is similar to the one before it, except instead of finding an equivalent fraction with 100 as the denominator, or instead of finding an equivalent fraction with 10 as the denominator, we're going to find an equivalent fraction with 100 as the denominator. So our example here, we have 3/20. I'd rather not draw a model with 20 sections and figure out what would be equal to it if there were 100 sections instead. So let's try it with the multiples. So again, we're going to write 3/20 and we're going to get everything set up for my equivalent fraction. And I'm going to start by listing the multiples of the denominator because it's the denominator that we want to be 100. So I have 20, 40, 60, 80, and 100. So there's 100, and I know I can stop there. And I know that 100 is 20 times 5 because I counted 1, 2, 3, 4, 5. So now I have 20 times 5. So I'm going to multiply my denominator by 5 to get 100. And then whatever I do to the denominator, I also have to do to the numerator. So I'm going to multiply 3 times 5, and I get 15. And I read this fraction as 15 hundredths. So if you think about what 15 hundredths looks like as a decimal, you'll know it looks like this, 0.15, because that 5 is in the hundredths place. So 0.15 or 0 and 15 hundredths is equal to 3/20ths. So now it's your turn. Think about 8/25ths and write it as a fraction in its equivalent decimal form. Try to think about try to make it so that you can get 100 as the denominator. So find an equivalent fraction first with 100 as the denominator. So go ahead and figure that out now. So let's look at how we can figure this out. So I have 8/25ths, and I'm going to set up my equivalent fraction, and I'm going to start by listing the multiples of my denominator. So I have 25, 50, 75, and 100. So 100 is where I want to get to. And if I count the multiples, 1, 2, 3, 4, I know that 100 is 25 times 4. So I'm going to multiply my denominator by 4 to get 100. And then whatever I do to the denominator, I also have to do to the numerator. So I'm going to multiply 8 times 4, and that's going to get me 32. And I read this fraction as 32 hundredths. So that means that if I write that as a decimal, it's going to look like this 0.32, because that 2 is in the hundredths place. So 0.32 is also read as 0 and 32 hundredths, or just 32 hundredths. So 32 hundredths is equal to 8/25ths. Now there will be times when you can't find an equivalent fraction with 10 or 100 as the denominator. And in that case, you're going to have to divide the numerator by the denominator. So we're going to start with an example that's pretty easy. So in this case with 3/4, you can actually find an equivalent fraction with 100 as the denominator, but instead we're going to use the division method. So to divide the numerator by the denominator, you have to think about the fraction bar as the division symbol, because this is actually mathematically true. The fraction bar is a division symbol because it means division. So I'm going to take 3 and I'm going to divide it by 4. So when we set up our division problem, something that we really need to remember is that the numerator will always go inside the house. A lot of times we like to put the bigger number inside the house here, on the inside right here. But we have to remember that the numerator, or the number on the top up here, or the first number over here, is the number that goes inside the house. The numerator is the number that goes in there. So I'm going to put the 3 in there, and then I'm going to put the 4 on the outside. If you aren't already familiar with the long division process, you might want to take some time now to go review that, because this is going to be a little bit challenging to follow if you don't already have an idea of the long division process. But you might be looking at this and saying, okay, well, 3 divided by 4, 4 is bigger than 3. I can't get any groups of 4 out of 3. And you would be right. But before we even start our division, we're going to list the multiples of 4 down the side of my screen. I like to list the multiples of my the number that I'm dividing by, because it helps me kind of go back to it as I'm doing the division without having to do all that division in my head all the time. So I'll show you what I mean by that. I can use this list to answer all of the questions I have while I divide. So the question is, how many groups of 4 can I get out of 3? And one group of 4 is 4, and I don't even have enough for one group of 4. So you would write a 0 on top of the 3. And 0 groups of 4 is 0. And when I subtract that, I end up with 3. So I still have my 3 left. And in the past, when you run out of numbers, you just say, okay, well, remainder 3. But now that we're trying to figure out what this fraction is as a decimal, we can actually add something to our 3 over here. So if this 3 is in the ones place, I can actually add a decimal point after it. And then I'm going to bring that decimal point up to the top part of my answer so that I have it up there. And then I can go ahead and add a 0. Now, adding a 0 after the decimal point didn't change the value of 3 at all. All it did was just gave me another number to work with. And now I can bring that 0 down. And instead of 3, I now have 30. So now we can continue on with our division. So the question now is, how many groups of 4 can I get out of 30? And this is when my multiples listed over here really comes in handy. I'm looking at 4. I can see I have 4, 8, 12, 16, all the way up until 28. 28 is not quite 30, but 32 is too much. So I know that I can only go as far as 28. And that was 1, 2, 3, 4, 5, 6, 7 groups of 4. So that means I'm going to write a 7 up here. And 7 times 4 is 28, just like I figured out over here. And when I subtract 30 minus 28, I end up with 2. So again, now that we're working with decimals, we're not going to have any remainders. So instead, what I can do is add another 0 after this number and bring it down. So now I have 20. The question now is, how many groups of 4 can I get out of 20? And if I'm looking over here, I see 1, 2, 3, 4, 5. There's 5 groups of 4 is equal to 20. So I'm going to write a 5 up here. And 5 times 4 is 20. And 20 minus 20 is 0. And now I'm finished. So my final answer here is 0.75 or 0 and 75 hundredths. And that is what's equal to 3/4. So I used division to figure out what this fraction is as a decimal. So now I want you to try this as an example. It's okay if you're still having some trouble understanding this, but see what you can do with 1/8. So take some time now to try to use the division method to convert 1/8 to a decimal. So let's look at 1/8. So if I have that fraction bar as division, and I write my division problem as 1 divided by 8, I'm going to set up my division problem. I'm going to remember that the numerator goes inside the house. So even though 1 is such a small number compared to 8, it does go inside the house. So I have 1 divided by 8. And then before I start my division, I'm going to list all my multiples of 8 down the side. So I have 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. You only need the first 9 multiples of 8, but I like to have the 10th one just in case. So I'm going to start again. How many groups of 8 can I get out of 1? And that answer is 0. Can't get any groups of 8 out of 1. So 0 times 8 is 0. And if I subtract, I end up with 1. And now, just like we did before, I can add a decimal point out after that 1, bring it up to my answer so I don't forget about it. And then I can add a 0. And adding a 0 after that decimal point doesn't change the value of this 1 at all. It's still 1 whole, 1.0. But now I have another digit I can work with, and I can bring that 0 down. So the next question is, how many groups of 8 can I get out of 10? And if I look over here at my multiples, I see 8 and then 16. 16 is too many, so I can only go to 8. So that's just one group of 8. And 1 times 8 is 8. And then I have 2 left over when I subtract. Now, again, we're not going to have any remainders here. So I'm going to add another 0, and I'm going to bring it down. And now I have 20. So how many groups of 8 can I get out of 20? And if I look at my multiples over here, I have 8, 16, and 24. 24 again is too many, so I have to go only at up to 16. 16 is 2 groups of 8, so I'm going to write the 2 up here. And 2 times 8 is 16. And when I subtract, I get 4. Again, don't want any remainders, so we're going to add yet another 0 and bring it down. And now I have 40. How many groups of 8 can I get out of 40? 1, 2, 3, 4, 5. 5 groups, because 5 times 8 is 40. So I'm going to write the 5 up here. Do 5 times 8 is 40. I subtract, and I end up with 0. So 1/8 written as a decimal is written up here, and it's 0.125 or 0 and 125 thousandths. This method works for any fraction. So even if it's an easy fraction, like a fraction with 5 as the denominator like we did before, you can still do this division method with that fraction as well. Now, I want you to make sure that you remember something. So we had 3/4 equals 0.75 and 1/8 equals 0.125. But what if we had those same fractions, but instead we wrote them with a whole number in front of them, meaning that they ended up being mixed numbers instead of just fractions by themselves. So there is nothing additional that you would have to do to convert these mixed numbers into decimals, because converting 3/4 into a decimal will be the same process. The whole number 7 and the whole number 2 are just whole numbers. So we don't actually have to do anything with these numbers when we convert them to decimals. We just have to make sure to put those in the whole number place value instead of a 0. So we would still convert 3/4 to a decimal, and we would get 0.75, but instead of writing the 0, I would write the 7. So I have 7.75 instead of 0.75. Again, you would convert 3/4 into the decimal and get 0.75, but instead of that 0 in your final answer, you would write the 7. Same thing with 2 and 1/8. I would again convert the 1/8 to a decimal using division, and I would get 0.125. But instead of writing that 0, I would write the 2 in the whole number place value instead. So now I have 2.125 instead of 0.125. So there isn't any extra work. You just have to remember to replace that 0 with the whole number. I hope this video helped you understand a little bit more about converting fractions to decimals. Feel free to watch it again if you need any help or need to be reminded of anything.